All right, in this video, we're gonna take a introduction of complex numbers and how we can kind of think of those as um, numbers like in what we call trig form. Okay, so it it's quite simple when you break it down, but it's quite complex when you just look at a ton of equations. Okay, so let's begin. The first off, in standard form, right? Like anything you have done in trig, we've dealt in terms of x and of y, right? And then we looked at, take any point and whether it's on the unit circle or not, like we know that this point is represented by x and a y, and we could find a representative right triangle in here. Let me use a different color, right? By looking at this angle theta, and let me just blow that up a bit. So if we had this angle theta, and then we knew that this side was x and this side was length y, right, in terms of this point xy, should have used the same color, right, that point there. Um, and then we did a bunch of trig with this. So one thing was like, we called this r, the hypotenuse r, right? And we said, well, cosine theta equals x over r, and we knew sine theta was y over r. And then we also could say, well, we had a right triangle, right? X squared plus y squared equals r squared. Okay, or you could manipulate this to say, x is r cosine theta, and y is r sine theta. And then on the unit circle, right, we had all these special values, and we knew r was 1. So anyways, to demonstrate how this changes with a complex number, it really just boils down to, all right, if you think of x as a, and b as y, okay, in simplest explanation, all of these forms that we previously learned still hold true. So let's take a look at that on a complex plane. Right? This was double R, like real, like we were dealing with real numbers here, x's and y's, and points. In the complex plane, the imaginary plane, we'll just say I, what we did is we let the x-axis be the real part, okay, the a, the real part of the complex number, and the y-axis be b, the complex part, the imaginary part, a plus bi, right? So when we graph this, we still have the same point, so I'm going to put it kind of in the same spot as the xy, but we called this a plus bi, right? What we did is we moved over a units on the real and up b units on the imaginary, but we could still draw its representative right triangle here. Okay, let me again blow that up. And now what we have is theta, right angle. This length was A, this length was B, right? And this point here was the A plus BI. So now when we find R, the formula that we had before, x squared plus y squared, still holds true, right? We have a right triangle, but it's a squared plus b squared equals r squared. Now, in complex form, what we usually call this distance r, okay, it's the distance from the origin, right? What is the length from the origin to that point, that complex number, right? We could still do Pythagorean theorem, but we often call that the absolute value form. So when we do r, we get square root a squared plus b squared, and what we call that is the absolute value of a plus bi. Okay, why is that? Because absolute value stands for distance. So if I want the distance from the origin to that point in the complex plane, it's still Pythagorean theorem. Okay, it's still square root a squared plus b squared. It's just a special notation that we call absolute value, right? So the absolute value of a complex number is essentially r. We're talking about the same thing here. Furthermore, we begin to use this trig notation when we begin polar form. Okay, so one way of graphing is this complex plane, but then we also have a way of graphing these trig numbers in polar form. So what does that mean? Well, remember A was kind of like calling X, right? And B was kind of like calling it Y. I mean, if we were to think of the real plane, A kind of matches up with X and B matches up with Y. They're not the same, right? A plus BI cannot be graphed in the real plane XY, the XY plane, with our Cartesian coordinate system. However, the identities are the same, right? The trig is the same. If I want a cosine theta here in the complex plane, well, I have adjacent, right? Adjacent is A, and then hypotenuse is R. So depending what you want, right, we could say A equals R cosine theta. Just like we had X equals R cosine theta. All right, or maybe you need to find A, for instance, and you know R and theta, then use cosine theta equals A over R. Anyways, sine theta is Y over R, which means, oops, I'm sorry, not Y. I was looking above, but we have B, right? We're in the complex plane. B is similar to Y, so B over R. So B is R sine theta. And like, what does that lead us to? Well, we already had made this connection of R and A and B. But if I wanted A plus BI, right, if I wanted that complex form in trig form, again, which we'll use for polar form, well then I can use both of these that I just derived, right? A plus BI is equivalent to saying R cosine theta is A, right? R cosine theta plus, so I made that substitution, plus R sine theta for B, I made that substitution, and then I still have this I. These two notations are equivalent, it's just different forms. Do you want the complex number form? Here's the complex number form, A plus BI. Or do you want the trig form? And you can almost see why it's called trig form, right? Because it has cosine thetas in it. Cosine and sine theta has theta, and then it has R. We have two unknowns. We need to know an R and a theta. and then I could write any complex number in trig form. And again, you could get r theta just using simple trig or Pythag, right? All of this boils down to knowing the Pythagorean theorem and trig to find an angle. The last thing is typically, so I'm going to say equals one more time. Typically what we do is we factor out this r because it's apparent in both, right? R cosine theta and r sine theta. And then we write cosine theta plus I sine theta. Usually we put the I first. Okay, only like that's common notation. So, which is kind of weird because A plus BI, right? We write the I last, but trig form, there it is. So hopefully that helps to see the absolute value of a complex number. Really what they're saying is just find R, right? And then how trig notation from complex numbers is apparent. Really it's finding A and B, and you find A and B by basic trig. It's just we're in this whole new form. Now, to end, topic for another video, but this really leads to polar, okay? Getting functions in polar notation, because polar only depends on these two things, r and theta, right? When you learn to graph polar coordinates, you need to know the distance from the origin and the angle that the point is in, and then you could graph equations and whatnot too, but they're always in terms of r, like think y is a function of x, right? R is a function of theta. You give me theta and solve for r, and you could get some pretty cool looking graphs when you go to polar notation.